Hey everyone, Mr. Kaczynski here, still traveling through IXL's Algebra 1 skills in section AA, get close to finishing it up. Factoring by grouping today. I introduced factoring by grouping a little bit in my last video where we were factoring quadratics whose lead coefficient wasn't 1. Take it a little bit up a notch here today. Alright, so usually you might notice that you can do factoring by grouping when there's 4 terms. So what I'm going to do is take the first 2 terms in this polynomial and I'm going to group them together, factoring by grouping. And I'll take the second 2 terms, the 4w minus 4, and I'll group those together. Then I'll look at this first grouping, what's their greatest common factor. Both of those terms are divisible by 9. They're also both divisible by w squared. When I factor that 9w squared out of the first grouping, I'll be left with w minus 1 inside. So 9w squared times w is 9w cubed. 9w squared times negative 1 is negative 9w squared. Then what can we factor out of the second grouping? They're both divisible by 4. Alright, so I'm going to take that out. And 4 times w is 4w, and 4 times negative 1 is negative 4. Notice inside the parentheses in the red there, we get the same expression. That won't always be the case every single time that you've got 4 terms. You can't always factor it. But again, not trying to trick anybody with these examples today. So w minus 1 is one of our factors. The other factor is this 9w squared plus 4. And that's our factorization of the original polynomial. If we multiply this times this, we will get this. Alright, let's do another one. Pretty straightforward, the process anyway, so it's a good skill to get this factoring by grouping down on IXL here. Let's take the first 2 terms and we'll group them together. And we'll take the second 2 terms and group them together. In the first grouping, they're both divisible by 9v squared. When we factor that out, we'll have 3v, as in 9v squared times 3v is 27v cubed, plus 4. You know what, I'm going to use different colors here. 9v squared, 3v plus 4. In the second grouping, I can factor a 4 out of each one of those. So 4 times 3v would be 12v. 4 times 4 would give us 16. So you can see in the red is one of our factors, 3v plus 4. And in the green is our other factor, 9v squared plus 4. And that's our factorization of that polynomial. Okay, on this one, all right, here we go. So let's group our first 2 terms. And we'll group our second 2 terms. Factor out of the first one, the best I can see is a z. They're both divisible by z. That would be 7. Again, let's do some different colors. Z times 7z plus 12. In the second expression, they're both factorable by 2. So plus 2. Times 3 plus 7z squared. Now notice what happened here. We didn't get the same expression inside the parentheses. So that kind of backfired on us. It didn't work. Does it mean it's not factorable? Not necessarily. Let's take the original expression and let's reorder it here. 14z cubed plus 7z squared plus 12z plus 6. Same four terms, different order. And then let's group the first two terms and the second two terms, and let's see what happens. Both of those first two terms are divisible by 7z squared, which would be 2z plus 1. And both of these second two terms are divisible by 6. And that would give us 2z plus 1 in the parentheses as well. So see, it was factorable after all, but we had to do a little rearranging sometimes. All right, sometimes you don't know that you have to do that until after you mess it up. Believe me or not, I actually knew it wasn't going to work the first time, but I was trying to illustrate a point. All right, here's another one. There is something I noticed, that they're all divisible by 5 and they're all divisible by j. I'm actually going to wait on that. So here's what I'm going to do. I'm going to group the first two terms, 15j squared k minus 15j squared. And I'm going to group the second two terms. I always put the plus sign in between them, and then I'll include the negative sign here. All right, the first term, or the first group, they're both divisible by 15, and they're both divisible by j squared. So that would be 15j squared times k would give us 15j squared k, and 15j squared times negative 1 would give us negative 15j squared. Second group, they're both divisible by, I always have to take out that lead one. They're both divisible by 5 and j. Okay, negative 5j times k would be negative 5jk, and negative 5j times negative 1 would give us positive 5j. So we've got, actually, 15j squared minus 5j is one of our factors, and our other one is k minus 1. But you'll also notice that this first grouping, there's still a common factor that can come out of that, and that's that 5 and j. So what we're going to do is factor that out of there. 5j times 3j minus 1. 5j times 3j is 15j squared. 5j times negative 1 is negative 5j. And then we've still got the k minus 1. So we've actually got, I guess you could consider it 4 factors here. We've got the 5, the j, the 3j minus 1, and the k minus 1. There's the complete factorization of this expression. One more that's kind of like that one. All right, I'm going to group the first two. And I'll group the second two, negative 4vw plus v. What can be factored out of the first two terms? V squared. That would leave me with 4w minus 1. Got my colors. 4w minus 1. And what can be factored out of the second two? How about a negative v? That would leave me with 4w minus 1 as well. So one of our factors is v squared minus v, and one of our factors is 4w minus 1. But the first expression, that first grouping there, that first factor, they have a common factor of v, so I'm going to factor that out and make it v times v minus 1 times 4w minus 1. So that would be the complete factorization of the expression. It's got 3 factors. V times v minus 1 times 4w minus 1. All right, factoring by grouping, tons of fun. I know you'll love it. Good luck on that skill.